Hey, hello and welcome to BYJU'S. My name is Nikhil and we are here for our NEET question paper discussion. Through this discussion, we will see what type of questions are being asked in the actual examination. We will also see what are their difficulty levels. So with all this in our mind, let's get started. Let's start with a question on semiconductors. But before that, let me take an opportunity to introduce you to our friend Difficulty Meter. Mr. Difficulty Meter says that the question is medium on the hardness scale. Now let's go to the question. Question says, for transistor action, which of the following statement is correct? So for transistor, which of these option is correct? Now, let's talk about transistor before we read the options. What is transistor? What is it made up of? It is made up of three regions. One is emitter, another is base, and the third one was collector. Yes. Now base is sandwich between emitter and collector. This is our transistor. So option A says both emitter junction as well as the collector junction are forward biased. Option A is unfortunately not true. Why not? Let's talk about junctions for a while. Junctions are emitter base junction and collector base junction. These are the two junctions. Now for normal functioning of a diode, emitter base junction is always forward biased and collector base junction is always reverse biased. So option A said both are forward biased. No. One is forward bias and the other is reverse bias. So option A is wrong. Option B says the base region must be very thin and lightly doped. Option B is perfectly true. It is indeed the case that the base region is very thin and lightly doped. Very lightly doped. And option C says base region and the collector region should have same doping concentration. No. They have different level of doping concentration. The base region is the one which is very lightly doped and emitter is the one which is heavily doped. Collector is the one which is moderately doped. So they have different level of doping concentration. So option C is wrong. Option D says base emitter and collector region should have same size. No. Base is the one which is very thin as compared to emitter and collector. They don't have same size. Option D is wrong. So as far as this question is concerned, option B is the right answer for this question. Here we have a nice question on electric field. The question is a medium level question. This is a formula based question. So the question says a spherical conductor of radius 10 centimeter has a charge 3.2 into 10 raised to power minus 7 coulomb distributed uniformly. So some charge is distributed uniformly on this round surface of this sphere. Okay. And then the question says, what is the magnitude of electric field at a point 15 centimeter from the center of the sphere? So there is this point at a distance of 15 centimeter from the center. We can see this point is outside the sphere. What is the electric field? What is the magnitude of electric field at this point? This is the question. Now let's say the point is at a distance r from the center. Now what do you think is the formula to calculate the magnitude of electric field? What is the formula? The formula is similar to a formula which we have learned for a point charge. The formula is kq by r square. Exactly, this is the formula, where r is the distance from center to point P. Now this formula is applicable only and only when the point is outside the sphere. If we have a point inside the sphere, then the electric field is zero due to this uniform charge distribution on the outer boundary of this sphere. Okay. Now let's apply the formula. The value of k is 9 into 10 raised to power 9 and q is given. It is given to be 3.2 into 10 raised to power minus 7, and we have the radius. Radius was 15 centimeter. We can write it as 15 into 10 raised to power minus 2 meter, and we whole square this. Okay. And when you solve, you will get 1.28 into 10 raised to power 5 Newton per Coulomb. So this is the electric field, and we can see that option D is the right answer for our question. Let's have a look at this question based on optical instruments, and we have a question on telescope. So assume that the light of wavelength 600 nanometer is coming from a star. Okay, the limit of resolution of telescope whose objective has a diameter of 2 meter is. Now we know what is the diameter of the objective lens of the telescope. We have to tell what is the limit of resolution. What is the limit of resolution? What do we actually mean by the limit of resolution? Well, the minimum angular separation between 2 points which can be resolved using the optical instrument is the limit of resolution of that optical instrument. And we have an awesome formula to calculate this minimum angular separation. We have the formula like this. This is 1.22 times lambda divided by d. What is d? D is the diameter of the optical instrument, and we can see in our case the objective lens has the diameter of 2 meter. Okay. Now let's put the values and get the value of theta minimum or delta theta minimum, and this is coming out to be 1.22 times lambda. What is this lambda? Lambda was given to be 600 nanometer. Now let's convert nanometer into meters. So we multiply by 10 raised to power minus 9. Yes. So we have converted nanometer into meter. And then the diameter is given to be 2 meter. So what are we getting? We are getting the value as 3.66 into 10 raised to power minus 7. Yes. So small is this angular separation or delta theta minimum. And now we can go and mark option C as the right answer for our question. Let's see this question on unit and dimension, and this is an easy one. The question says dimension of stress. What is the dimension of stress? And these are the options. Well, we know the formula of stress, don't we? Formula of stress is force per unit area. Force upon area. This is the formula for stress. And the dimension, well, this is easy. You know, force is mass into acceleration. So the dimension of force is m L t raised to power minus 2. And the dimension of area is L square, right? Okay. And we can see the dimension of stress will be m L raised to power minus 1 t raised to power minus 2, right? Okay. So option B is the right answer for our question. Here we have an awesome question on screw gauge. A screw gauge has least count of 0.1 mm. So least count of this screw gauge is given. Alright, and there are 50 divisions on its circular scale. So we know the number of divisions on the circular scale also. The pitch of the screw gauge is. So what is the pitch of the screw gauge? This is the question. Now what do we really mean by pitch? What is this pitch? Pitch is nothing but distance moved by the spindle horizontally when we have one complete rotation on the circular scale. Or you can say distance moved by the spindle per revolution. This is the definition of pitch. How do we calculate pitch? Very simple. See, there are 50 divisions on the circular scale, right? If we turn the circular scale by one step of circular scale means 0.01 mm distance moved by the spindle, right? For one complete revolution, how many steps are there? There are 50 steps. So 50 steps will mean about 0.01 times 50. This is the distance moved by the spindle when there are 50 steps. Do you agree with that? Okay? Yes. Now this will give us the pitch. And we can see that this is coming out to be 0.5. 0.5 what? mm. Because there we have 0.01 mm. Yes. So option A is the right answer for this question. Now, as the question on screw gauge has come, I suggest you can mug up this formula if you haven't right now. This is the formula. Least count is equals to pitch divided by number of divisions on the circular scale. Pitch is the distance moved by the spindle for one complete revolution, and if there are n divisions in the circular scale, then pitch divided by n is equals to least count. This is the formula. And we can go now and mark the correct answer. Option A, we found 0.5 mm to be the right answer for this question. Here we have a question on Newton's laws of motion. The question is based on Pulley mass system. The question says, two bodies of mass 4 kg and 6 kg are tied to the ends of a massless string. And the string passes over a pulley which is frictionless. Okay. The acceleration of the system in terms of acceleration due to gravity is. So what is asked? It is asked what is the magnitude of acceleration of these masses. We can see the acceleration has the same magnitude A, but the direction of the acceleration are different. 6 kg is the heavier one, so it will accelerate in the downward direction. Okay. Now let's try to tell this A in terms of G. Okay, let's begin. Now, on 6 kg mass, what are the forces? One force is mg. This is 6g in the downward direction. And another force will be tension T in the upward direction. Okay? Now, let's go to 4 kg block. There is mg on this 4 kg block as 4g in the downward direction. And there is tension T in the upward direction. Okay? Yes. Now, let's quickly write the equation. For the 6 kg block, we have 6g minus t is equals to 6a. And for the 4 kg block, we have t minus 4g is equals to 4a. Yes? Okay. Now, let's quickly add these equations. When we add them, we are getting 2g is equals to 10a. 2g is equals to 10a. This means the acceleration comes out to be g by 5. Hooray! We can mark option A as the right answer for our question. Here we have a question based on de Broglie wavelength, and this seems hard. The question says an electron is accelerated from rest. An electron is accelerated from rest through a potential difference of V volt. So let's imagine an electron which is approximately at rest, and this electron enters a chamber. So the chamber has a potential difference of V volt. Okay. So this electron, after entering the chamber, comes out of the chamber. And you can guess what happens to this electron. It will gain some kinetic energy. Now this electron is moving. Okay. The question says if the de Broglie wavelength of the electron is 1.227 into 10 raised to power minus 2 nanometer, find the potential difference. So what is this potential difference V when we know what is the final de Broglie wavelength? Now there is a crucial formula for finding this final de Broglie wavelength. What is the formula? The formula is like this. Lambda. This lambda, the de Broglie wavelength is nothing but 12.27 divided by under root V. And one important point is that this lambda is given in terms of Armstrong by using this formula. So this is the formula to calculate de Broglie wavelength. Now what do we know in our question? We know what is lambda. We know the de Broglie wavelength, but we know it in terms of nanometer. So let's quickly convert that into Armstrong. So we can see that lambda, we can see the lambda is nothing but 0.1227 Armstrong. So we have converted nanometer into Armstrong. Now let's quickly put this lambda and get the value of V. So under root V is coming out to be 12.27 divided by 0.1227, and this is nothing but 100. So under root V is 100. This means V is 10 raised to power 4. Yes, and option B, 10 raised to power 4 volt, is the right answer for our question. Now you might ask, wait. You have given us a formula. We can remember the formula all right. But how does this formula come into the picture? Well, I will give you the way out of that. So you can imagine that when the electron comes out of this potential difference V, we have the final kinetic energy of the electron, kinetic energy final, as charge of the electron E times the potential difference V. Okay, so this is the kinetic energy of the electron. Now we can write the kinetic energy in terms of momentum. Kinetic energy is equals to P square by 2m. Yes? Okay. So we know what is kinetic energy. It is EV. So we can say EV is equals to P square by 2m. From this we can calculate what is momentum, and you can say momentum is equals to under root 2m EV. Okay? Yes. Now once you know the momentum, you know what is the de Broglie wavelength. How? Do you remember the formula for de Broglie wavelength? Yes, we do. What was the formula? Formula was lambda is equals to h by p. Exactly. And when we put the values, you can see we are getting h by under root of 2m ev. We can see that this lambda is inversely proportional to under root v. Can you see that? Okay. Now from this we get our required formula, and once you place the values in our required formula, you will get the answer to be 10 raised to power 4 volt. This was the potential difference, and option B is the right answer for our question. Here we have a question on electric field. The question says that in a certain region of space with volume 0.2 meter cube. So you can imagine a certain region of space, its volume is 0.2 meter cube. So this is our region and its volume is given to us. The electric potential is found to be 5 volt throughout. So the electric potential is same. It is 5 volt throughout. 5 volt throughout. Okay. The magnitude of electric field in this region is. So what is the magnitude of electric field? Now, what is the formula for electric field in terms of potential? What is the formula for electric field in terms of potential? You would say E is equals to minus dV by dr. Exactly. So this means when V changes with R, when the potential changes with R, the distance, then we get the electric field, right? Right. And we can see in our case the potential is constant. So when dV is equals to 0, electric field is also 0. Isn't it true? Okay. So option C, 0 is the value of electric field. Option C is the right answer for our question. Here is a question on ideal gas equation. And you know what? This question seems to be very, very, very easy. The question says that a cylinder contains hydrogen gas at a pressure of 249 kilopascal and temperature 27 degrees centigrade. What is the density? So simple. So what is given? First of all, they gave us the gas is hydrogen and the pressure is given, the temperature is given, and we also know what is the value of R. What is asked? The density of this gas. What is the value of rho? This is the question. Now, by any chance, do you remember what is the ideal gas equation? You would say, ideally, we know that. So, the ideal gas equation is PV is equals to nRT. Very nice, very nice. But there is a variation of this equation. The variation is like this. PM is equals to rho RT, where rho is the density. And we had to calculate what is rho. So, let's get the formula straight. PM divided by RT. What is M? M is the mass of 1 mole. M is the mass of 1 mole of this gas. Now you can see the gas is hydrogen. So M is nothing but 2 gram per mole. So this is 2 into 10 raised to power minus 3 kg per mole. Okay. And P we already know is 249 times 10 raised to power 3 Pascal. Okay. Yes. And then we have temperature. Temperature is 27 degrees Celsius. We can write it as 300. Okay. So let's put the value of temperature as 300. And what is R? R is given to be 8.3. Well done. Well done. Now when we calculate, we will find rho is coming out to be 0.2. Yes, it is 0.2 kg per meter cube. And let's go and let's mark option D as the right answer for this question.